Okay, so question 5. A cyclist is riding at a steady velocity of 12 meters per second. Okay, so let's draw ourselves a little diagram. Here's our cyclist, and they're going along at a speed of, their velocity is 12 meters per second. He's just about running out of room there. The cyclist and the bike have a total mass of 68 kilograms. So M is 68 kgs. The cyclist starts to cycle again. Now, I don't quite get this question because they were cycling here. It doesn't say they've stopped, but they've started to cycle again. So I'm not too sure about the wording of that question. But hey, they're cycling again. The cyclist does 1,600 joules of useful work to travel 28 meters. So they've done that much work to travel that far. Calculate the average force that the cyclist exerts. So we need to think about work done, forces and distances. So for this question, we need to remember one of our equations. We had Elvis Presley must go home. The next one in that little sequence we learnt was when Fred sings. The work done, or the energy transferred, is the force times S. Now, it's really key here to know what S means. S is not the speed. You remember speed, we used a V for velocity for speed. S, I'm going to do it in red here, S stands for the displacement. So that's just the distance in a set direction. So we need a displacement, force, and the work done. So let's think about, what do we know in this question? What are we given? Well, we know that the work done, the useful energy, the energy that's been transferred, is 1,600 joules. We want to know the force, and we know that they've transferred that energy in traveling 28 meters. So a little bit of rearranging. F is going to be 1,600 over 28. Again, I think that's a job for a calculator. 1,600 divided by 28 will give me an answer of 57.142. So let's round that off. All our numbers here are to two significant figures. So let's round this to 2. So F is 57. It's a force, so we're in newtons. You could have made a slightly different approach here, folks. You could have gone, let's change back to black. You could have gone W equals Fs. And you could have rearranged it first. So look, we're after the force, so that would be that. The force is the work done, 1,600, all over the displacement, 28. You'll notice here we have the same calculation, just depends on when you do it. Personally, I like this way, but if you struggle with the maths, or if you're not really confident with your rearranging, stick to this format here. You'll get the full mark still, assuming you do everything right.